Hi guys, welcome to the channel. Welcome to today's daily problem that we posted in the morning. Hope you have read the question. Let me reread the question and come up with the solution for this. Okay. The question states this is a Leetcode 1186 question, maximum subarray sum with one deletion. Even the question says one deletion, don't see this title. Like if you see the question, it will talking about at most one element deletion. It's not like mandatory one deletion, at most one deletion. Given an array of integers, return the maximum sum with at most one element deletion. Note the subarray needs to be non-empty after deleting the element. Like if there are only one element, in that case you need not delete it because they want the non-empty one, right? And since they are telling at most one, here the zero deletions happens. In other cases we can do either 0 or 1, but here it should be 0 deletions. If you go through the examples, the first array is 1 minus 2 0 3, and the maximum subarray sum that we will be getting from this is 4. How we will be getting 4? In our case, we can see like which element to be deleted. If you are trying to delete 1, in that case we will end up with minus 203 or minus 203. So if you see, or if you generate all the subarrays and see what is the maximum sum that you obtained, you will find the 4 as the one after deleting the 0. But even if you see, if you want to do it by generating all the subarrays, you will understand, you will get it in a clear way. So try to generate all the subarrays and try to delete, and try for all the possibilities, like once for deletion and other for not deletion. And if you see the same other example, 1 minus 2 minus 3, in this case if you try to find all subarray sums, you will find that 3 is the one that is the maximum. And if you see like without deletions, that is the 3, and with the deletions you will find the one element which is less than the existing sum. So in our case output 3 is this 3 is the output, and this is the other case. And if you choose all at once, the value gets reduced, right? Like minus 1 minus 2, almost minus 4, it is reduced. But if you want to choose the maximum, like minus 1, you can choose it. Since all the negative elements, in that case choose the one element. All negative, choose any one, that will be the max. If only one element, don't delete it, return that as an answer. Okay, that is an answer, like array of 0. Since the constraints are 10 power 5, we can't write our brute force solution. So how do we do this solution? Hope you have get some idea, because if you see, we are having the array that is not only having, if you are given an array with few integers, both only positive integers, like if 1 2 0 3, in that case obviously we can tell what is the maximum subarray sum by including this. But if deletions are allowed, we will try like whether we can delete this element or not, whether we can delete this or not. For each index we will check, and then we will come up with one solution that will take order of n only. But here the complexity is, even the given array is having negative elements, like this given array is having plus 1 minus 2 0 3, if we are talking about example 1. In such cases, to find the maximum sum, subarray sum, here we can use the sliding window approach, since it's having only positive elements. But here, since we are having negative elements, we will miss the concept of shrinking, like when to shrink, what to shrink, whether we can delete it or not. All those cases will fail. So sliding window doesn't work here. So what you can do is, you can go with the cadence algo. I will give some insight like what is the cadence algo. This cadence algo says that if you encounter, like when you try to do, like I'll write on for this example. This algo says take one sum variable and initialize with 0 and keep adding it, and to track the maximum, like we are taking one max variable and initialize this to minimum value, that keep that value as integer dot max minimum value in Java, okay, or minus infinity, whatever. So once you initialize this, you have to run a loop 0 to n and sum it up the nums of I. If at any point of time, if our sum becomes negative, if you, in your case, like 1 minus 2 gives minus 1, and if you keep on adding the other elements to these negative elements, other value also gets reduces. Individually it is 3, but if you keep on adding, for this minus 0 1 minus 1 plus 0 plus 3, it is reduced to 2. So what you have observed, whenever you encounter negative element, you try to ignore it or reset it. Reset your sum. Reset the sum. That means sum should become 0 and do a fresh start. If sum is less than 0, just reset it and again do a fresh start. Like again your sum becomes 0, that the previous sum will be 0 and it will be get added as a fresh. In our case, 3 added in such a way, like you will be getting the max value as 3. The cadence algo tells this, and you have to keep track of maximum also, right? Whatever, whether the fresh start is giving you the the maximum, or the extending the previous element is giving you the fresh maximum. So you compare both max of sum comma max c and return the max sum. Okay, this is the cadence algorithm. In this case, what is happening, they are giving an array which is having both the positive and negative numbers, and they are asking us to find the maximum subarray sum. You are finding the maximum subarray sum by following this greedy approach. Like whenever you are encountering minus 1, we know that going forward this negative will reduce the upcoming positive elements value also. So that is the reason whenever you encounter negative value, once we sum up, you have to reset it and then continue with the next elements. And for everything, like for every addition, you take the max and try to return the global max. Okay, this is the cadence algo. Now the slight modification for this question is, what they are asking is, now they want what is the goal of this question. Like they are asking us to find maximum subarray sum, but with one deletion or at most one deletion. That means at max one deletion. Here this cadence algo, whatever we have learned earlier, it should be having no deletions. So how can we use this kind of algo here? It's not like you have to use this algorithm only. Like if you can think other ways, that is fine, like you can code it. But since we already learned this cadence algo, it's better to think in terms of cadence algo. We can also think a sliding window, but this is having negative numbers, so it is not eligible for doing window sliding and all. So the known approach is sliding window. So the approach, what is the intuition for this? First, before going to the approach, first you need to understand what we are doing, right? Since we are trying to find the maximum subarray sum with at most one deletion, previously, like in the yesterday's video, we have talked like longest subarray having all the ones with deletion of 1 0. That is also 1 0, right? We have to delete 1 0 and we have to find the longest subarray by removing that 0. In that case, what we are doing, here we might be having some ones and here we are having other ones. like right side ones, left side ones. If we delete this one, since it is disturbing the entire like length, we are deleting it and combining the left part and right part. Similarly, in today's question also, we are observing the similar pattern. Like if you observe, we are having some element, like in our case -2. If these are the values 1 2 0 3, adding -2 is reducing the sum, right? Previously 1 minus 1 is the sum, but once we add -2 it became -1, and that is reducing to less than 0. It is going negative. So whatever you add after this element, it keeps on going reducing the value. So we have to reset it. So we have to check like whether we can delete this element. Will it is it possible to delete, and if we possible, is it resulting in maximum subarray? And if you possible, if you are trying to delete this, what are the solutions? Like, so we have to check for every index here. In the previous question, like yesterday's question, in the DSM1 video, like you will be seeing like there is a 0 and you have to see of that deletion. But here every index might be a possibility, but mostly the deletion can be on the higher side on the negative elements. Like negative elements should be deleted since it affects the sum. So it is not like you have to collect all the minus negative elements and keep it in another index and you can do, because that cannot be done. Because if it is having only one negative element, you can do, but if you are having another negative element, this process you have to see like what is there on the right and what is coming in front of it. So better to maintain two arrays. One is for the left array, other is for the right array. What it indicates is, let me show you. For each index, maintain two arrays. Like this is the given example. These are the indexes. So for each index I see what is the maximum subarray that will be ending till I-1, and if this is the index I, and what is the maximum subarray sum that is starting from I+1. Got it? Like if you could able to relate with the previous yesterday's question, like we have ones 0 1 1 1 till I-1, we have 1. This is the I and this is the I+1, right? So when you want to maximize the length of the number of ones, what you are doing, you are trying to delete this one and adding this left count plus right count, right? Similarly, if you want to delete this, if you plan to delete this, then you have to get this sum, left sum, right sum. So overall it will be L sum plus R sum. And again I am telling, this could be a potential value. This is the current sum. This could be a potential maximum, but it's not the maximum. So keep track of max for every current sum. Like keep max of current sum, comma max sum, and ultimately once you loop in all the indexes, you return the max sum. But here the question is like here you will be getting one doubt. How do you count how many max sum, like for each index, how do you find? Like you should be getting this doubt. How do you find for each index I, the max sum ending at I-1 and max subarray sum starting from I+1. This is the main thing here. So for this one, what we will be doing is, since we already learned the cadence algo, we will follow the same thing. Like we will be creating two arrays. On the left array, for this I, we will be creating left array, and this is the right array. Okay, or we can call it as forward array, and this is the backward array. So for this example, if you take, these are the indices, scan through the left to right and create the left array or the forward array. Okay, what you will be doing, how do you calculate the sum? Like for each index we have one options, like either start fresh or extend the previous element. So using this two choices, fill this forward array. Like if you consider forward array, it is looping from 1 to n. Like forward of 0, you just initialize with the existing 0 value, and for each value from looping from 1 to n, the forward of I should become the maximum of both of these, right, ending at each index. So max of what is the forward index, the previous index plus the current value, that is a of I, or if you want to start it, this is called extending the current element, and this is the starting fresh. Like I told you, right, in our case, for each index, like what are the subarrays ending with, first to write the subarrays ending with each index. For the 0th index, 0, 2, 3, there is only one subarray, and for 1 ending with 1, we have the fresh one and or the previous element combination. This is called two choices that I am talking about, starting the fresh or extending from the previous. You have to see which gives you the max. If you see, this is the -2, 1 minus 2 is -1. Out of this, which is the maximum, the current maximum, that is -1, right, out of -2 and -1. So that you store it instead of checking like -2 for all the subarrays and adding unnecessarily. You will be deciding if it is, if you consider the -1, the next time, like when you are seeing the subarray ending with 2, you will be having 0, -2, 0, 1, -2, 0, right? In this case, what you are doing, like the value is 0, value is -2, here is -1. So you need not consider all these values since you already got -1. Obviously, the one that is having either the fresh start or out of these two, like you already having -2, 1, -2. For this one, which one to add 0? We already know like -1 is giving the maximum value. So you can directly consider this 1 -2 part, you can ignore this part. So you understood, right? Like if you follow this comparison, and if you want to go with the start or extend the previous element, you will be neglecting the some values, neglecting some subarrays which are irrelevant. So we are doing this for every index, and finally once you are taking the max of locally, you will be getting ultimate max for this subarray sum. Okay, that you store it in, ultimately you will be getting this maximum value for each one, and you will be max. So far also you try to find whatever the max of maxi comma forward of I, that you see, and you will be having that value. And similarly you create the right array. You just traverse from back to, like right to left. This time you try to initialize the right of n-1 with the a of n-1 and do the loop from n-2 to 0 and fill the values either right array or backward array. Try to fill these values backward of either starting. What this backward array indicates, like backward array is meant for capturing the maximum subarray sum starting at exactly index I. At index I, this is maximum subarray sum ending at index I. So if you fill this backward array of I plus 1 plus array of I, this is extending from that array to the right, this is extending from left, this is extending from right, comma, or start a new element like a of I. We have to get the maximum like this, and ultimately you can get the ultimate max. Now you need to add for each index. What you have to do, like as I told you, for each index you have to calculate for each index you have to calculate answer that you just initialize with max so far, because this might be one of the reasons without deletions. This is without deletions case. So for each index deletion, this is answer 1 or answer, you can keep, update the answer, that is max of current answer, like without deletions, whatever we got this forward array or backward array, to the deletion one. How do you delete it? I told you, right, for each index you have to add the forward array plus backward array, the previous element sum ending at I minus 1, and the backward array indicates like the starting array, the sum starting from I plus 1. So ultimately what you will be having after this for loop got run, you will be having the ultimate answer which compares the maximum of deletions and without deletions and with one deletion. You have to return this. So if you see, the time complexity of this approach is order of n for this one and order of n for this one, and we are also creating one more index, one more, we are iterating over one more index to order of 3n. So overall it is order of n. The space complexity, we are using 2 extra arrays, that is order of 2n, so equal to order of n, one for forward array, other for backward array. Hope you understood the question. I am not giving the code for this, hope you can write it. If you want, I can attach the code in the description. Please check it out. Thank you.